Hello students, I welcome you all to my YouTube channel, which is entitled as Thermal Engineering by Manoj Shendre. So today we are going to discuss uh, about the course content of course Energy Conversion Laboratory, which is exclusively for 5th semester BTU students. So this is the lab which is entitled as Energy Conversion Laboratory. It is entitled as the Energy Conversion Laboratory. So we'll discuss about the what are the course objectives of this particular course, and also we'll discuss what is the course content of this particular subject. Okay. So the title of this course is Energy Conversion Laboratory. So this subject has course code 18MEL58, and the maximum internal assessment marks is 40 and the external marks is 60. So examination duration is 3 hours and total 2 credits are allotted for this particular course. Now let me explain about what is the learning objectives of this particular course. This course will provide the basic understanding of fluid properties and its measurement using various types of measuring devices. So here we are going to measure the various properties or the fuel properties of various types of fuels like petrol, diesel, kerosene, etc. by using the various measuring devices. Say for example, if I want to get the flash point and fire point, so we have to use the open cup or closed cup measuring devices. Okay. Similarly, if I want to calculate the viscosity of a particular lubricating oil, then we have to go with the redwood viscometer or Seabolt viscometer. So overall, we are going to calculate the various fluid properties, the values of various fuel parameters like viscosity, flash point, and fire point by using the various measuring instruments. Okay. So we'll see what is a flash point, fire point, viscosity, etc. in upcoming video sessions. Okay. So just remember the first learning objective of this course is to provide the basic understanding of fuel properties and its measurement using the various types of measuring devices. The next important objective is energy conversion principle analysis and understanding of IC engine will be discussed. The application of these concepts for these machines will be demonstrated. The performance analysis will be carried out using the characteristic curves. So we have various uh, engines like two-stroke engine, four-stroke engine, diesel engines, petrol engines, multi-cylinder engines in our laboratory. So for each and every machine, we are going to conduct the performance test and we are going to calculate the performance parameters of IC engines like the indicated power IP, the brake power BP, the frictional power FP, mechanical efficiency, thermal efficiency, that is a brake thermal efficiency, indicated thermal efficiency. Okay, so these are some performance parameters of the IC engines. So after calculating the values of these parameters, we are going to plot the performance curves. Okay, the performance curves for the further analysis. Okay, so already you have studied how to calculate the values of ip, bp, fp, mechanical efficiency, various types of efficiencies in your applied thermodynamics course in one of the module, that is IC engines. Okay, the last objective of this course is exhaust emission of IC engine will be measured and compared with the standards. Okay, so this is popularly known as exhaust gas analysis. So basically, we are going to collect some volume of the exhaust gases, and we are going to study what is the percentage of carbon dioxide, what is the percentage of carbon monoxide, what is the percentage of the water vapor and other remaining gases present in the exhaust gases. Okay, so this is a third main objective of this particular course. Okay, now let us do let's have an overview on what are the different experiments that are there for your syllabus. The part A, so part A is basically known as, it is a list of minor experiments, and part B is mainly concerned with the major experiments. In part A, the first experiment, this is a basic information about the lab layout, calibration of instruments, and the standards to be discussed. So in the first part, the part A, the first one is lab layout. Okay, what should be the structure, or what is a layout of lab? Okay, so that will be seen in the first case or the first experiment. uh, will go with the second experiment, that is a determination of a flash point and fire point of lubricating oil using Abel Penske and Martin's apparatus, which is also known as closed cup apparatus, and the Cleveland apparatus, which is also known as open cup apparatus. So as I said, we are going to define the flash point and fire point of the lubricating oil. So basically in this experiment, we are going to take the sample of kerosene, diesel, and other lubricating oil, and we are going to calculate the flash point, what is the flash point and what is the fire point of these fuels, by using the two apparatus, namely the closed cup apparatus and the open cup apparatus. This is a very interesting and important experiment. So we are going to list out the various values of temperatures, the various values of temperatures. Okay, so how to conduct the experiments, and what are the precautionary measures to be taken, so that will be seen in detail while conducting the experiment. Okay, now the third important experiment is determination of calorific value of solid, liquid, and gaseous fuels. Okay, I think you know about the calorific value, the definition of calorific value. Okay, so if you don't know, just look at here. So this is a sample of fuel. Let me take a solid fuel of the mass 1 kg. The mass of this solid fuel is 1 kg. Now under the controlled condition, say for example this is a chamber, say for example this is a closed chamber. If I ignite this fuel, if I ignite this fuel, then the burning will proceeds, it will undergo the combustion process. Now the total heat energy developed by the combustion of this fuel, by the combustion of unit mass of fuel, is known as calorific value of that particular fuel. Okay, calorific value of that particular fuel. So this is a very basic discussion about the calorific value. Now, for the solid fuel, for the liquid fuel, and for the gaseous fuel, we have the different setups to calculate the value of calorific value. Okay. Now, for the solid and liquid, for the solid and liquid fuels, we are using the bomb calorimeter, BOMB, bombs calorimeter, and for the gaseous fuel, we are using the Junkel's calorimeter. Both the experimental setups are there in our laboratory. So the detailed discussion will be done while conducting the experiment. Just for time being, remember the calorific value, the definition of calorific value, as well as what are the different instruments which are used to calculate the calorific value for the solid, liquid, and gaseous fuel. I repeat, for the solid and liquid fuels, we are using bomb calorimeter, B-O-M-B, bomb calorimeter. Okay, bomb calorimeter. And then for gaseous fuel, we are using Junkel's calorimeter, Junkel's calorimeter, Junkel's calorimeter. Okay, well, and the last experiment in the first part is valve timing or port opening diagram of an IC engine. Okay, this experimental setup is also there in our lab. So we are going to perform the exclusive experiment on how to draw the valve timing diagram, that is concerned with the port opening diagram. It is also known as the port opening diagram. That means it indicates what is the angle of crankshaft at which the opening and closing of valve takes place. Okay, valves and ports. So if you are using the diesel engine, so we have the valves, and if you are using the petrol engine, we have the ports. Okay, fine. So this is all about the discussion on the minor experiments, so from experiment number 1 to 5, and the part B is mainly concerned with the major experiments. In the major experiment, the first one is performance tests on IC engines, calculation of IPPP, thermal efficiency, volumetric efficiency, mechanical efficiency, specific fuel consumption, friction power, air fuel ratio, and heat balance sheet. So in our lab, we have 4-stroke diesel engine, 4-stroke petrol engine, multi-cylinder diesel engine, petrol engine, on which we are going to conduct the modes test, and 2-stroke petrol engine as well. Okay, so on these particular engines, we are going to calculate the performance parameters like FP, BP, thermal efficiency, volumetric efficiency, mechanical efficiency, etc. Right? And after that, we are going to plot the curves. After that, we are going to plot the curves. Okay, fine. Now, variable compression ratio. For this particular engine, we are going to draw the heat balance sheet. I hope you have studied already. You have studied about the heat balance sheet, how to draw the heat balance sheet in applied thermodynamics subject. That is in the module heat balance of the heat that is IC engines. The model name is IC engines. Okay. The next important experiment is measurements of exhaust emission of petrol engine. So as I said, in this experiment, we will conduct the performance test on petrol engine, and after that, we will collect the sample of exhaust which is emitted from the petrol engine, and after that, we will see what is the percentage of carbon dioxide, carbon monoxide, water vapor, and other contents in those exhaust gases, sample of exhaust gases. Similarly, the same thing will be repeated for the diesel engine as well. That is on experiment number 8. The part C is optional. Okay, if possible, we will visit the nearby automobile industry or the service station to observe what are the different parameters that will be considered for the service and how the service is done, okay, etc., for the automobiles. Okay, the last one is 10th, which is also the optional one: demonstration of p theta PV plots using computerized IC engine test rigs. So this experimental setup is also there in our automobile engineering lab. Okay, so we'll see in detail while conducting the experiments. Okay, so this is all about the syllabus or the course content. Now we'll see the scheme of examination. So this is exclusively for the external examination. Okay, the one question is from part A, that is for 30 marks, and one question is from part B, that is for 50 marks, which includes the write-up part as well as the calculation part. Okay, next one is viva voce, so total is 100 marks. So this 100 marks is converted into 60 marks, because while finalizing the grade, those external marks will be converted out of 60 marks. So 100 marks will be converted out of 60 marks. Okay, fine. So if you have any confusion anywhere, you can put your comments in the comment box. Okay, so please don't forget to like the channel, share the channel, and subscribe the channel, and share this channel among your friends. Okay, so don't forget to put or to press the bell icon, so that whenever I put a new video on YouTube, you'll get the notification instantly. Okay, so in the upcoming videos, we are going to see how to do the demonstration, or how to perform the experiments in lab. Okay, so thank you and have a nice day.